inside of the coordinate plane, right? So we learned a couple of vocabulary words yesterday. We learned about dilation, which means to make an image bigger or smaller. So the image is going to get bigger or smaller. And we also learned about the idea of where they say by a factor of 2. Now when they say by a factor of 2, remember when you have a scale factor it means to multiply. Okay. Now when we multiply these, we're actually going to multiply both the x coordinate and the y coordinate by this scale factor of 2. So we would take this 0 and multiply it by 2, and we would take the 2 and also multiply it by 2, and that would give us our new coordinate for a prime, which is 0, 4. Okay, and then we would do the same thing to all the coordinates. So I'm going to take this negative 4 and multiply it by 2, and I'm going to take this 0 and multiply it by 2. That'll give me my new b prime coordinates of negative 8, 0. And I'm going to do the same thing to c. C is going to be multiplied by 2, multiplied by 2. So c prime becomes 6, 8. Alright, so now what I'm going to do is I'm actually going to plot those points. A is 0, 4. Excuse me, a prime is 0, 4. B is negative 8, 0. Here is b prime. And C would be 6, 8. Sorry about that interruption. 6, 8 is going to be where C prime is. Okay. So what we have here are new coordinates, right? So what we want to look at is the actual notation for what we just did. Now a dilation, the letter would be a capital D, and we dilated all the coordinates by a d of 2. Okay, so when we see d2 versus d, and that's an O, not a 0, O2, okay, they mean the same thing. This is a dilation about the origin of 2. We're going to get into what that means in this very first question. Alright, so this very first question says to verify that the C prime is twice the distance, twice should look familiar from our scale factor up above, from the origin as C. So we're looking at that word distance, and we have done it before. So what we're trying to find is the distance from O to C, which O is the origin in this case. And we also need to find the distance from O to C prime. Okay. Well, if we did our dilation correctly, O to C would double to get to OC prime, and that's what we're going to verify. So remember, this is where we would create that right triangle in order to find the distance. This is where we would calculate the rise and the run to get the distance between these 2 points. Okay, so if I do the rise, that's 1, 2, 3, 4 up, and 1, 2, 3 to get to C. Right, that becomes my A, and that becomes my B value for rise and run. So my A squared would be the 4 squared plus the run equals the OC. Now if we put this into our calculator, this comes out as 25. And now remember, at the end we have to take the square root. So the square root of 25 is 5, which that's the length of OC. Now knowing that, if I did it correctly, I should get a value of 10 here. Let's find that out. Let's calculate the rise, calculate the run. That's a rise of 8, so we're going to do 8 squared plus the run 6 squared. Okay, if you put this part into your calculators, you're going to get 100. And then the square root of 100 is 10. So indeed, the distance is now twice as long. Okay. Now we're going to look at one more concept. All right, so a dilation definitely does change the coordinates by multiplying it by 2. But it also changes the length of the sides, if I was to connect these, by 2 as well. So if it was a scale factor of 3, it would be 3 times as long. If it was a scale factor of 1/2, it would be half the length. Okay, so now we're going to discover something that's new that we need to understand. They're asking us now from the slope from B to C. Okay, so here is B, there is C. So I'm going to find the slope. Well, we just did it when we were finding distance. So I'm going to count up. 1, 2, 3. That's a rise of 4. And a 1, 2, 3, 4, 5, 6, 7, and a run of 7. So the slope of BC is a rise of 4 and a run of 7. Now remember, we multiplied by 2. So chances are the slope's going to also multiply by 2 as well. So now if I did this correctly, I should get 8 over 14 if I connect from B prime to C prime. So let's take a look at that. If I connect from B prime to C prime, I'm going to calculate my rise, and I'm going to calculate my run. So let's rise. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Now I'm going to calculate the run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep. Okay. But I do want you to notice that that can reduce to 4 over 7. If we look in this picture, we can kind of see what's supposed to be true, and we just proved it. If I look from B to C and B prime to C prime, I can see what I'm about to write is going to be true. The fact that BC is parallel to B prime, C prime. And again, this symbol meant parallel. And I can prove it because they have the same slopes. So that brings us down to the two primary properties of dilations, right? Okay, so when we dilate a segment not containing the center here, the scale factor produces scale factor of k, remember that's what we're using, produces a prime b prime. So that means the length of AB, we would just take the length of AB and multiply it by k to get the new one. Now sometimes it'll get bigger, sometimes it'll get smaller. Okay. And the one thing that we just discovered in the step up here is that this segment here is going to be parallel to the new dilated one. Okay, and that's what we're looking for here, is parallel. Okay, and again, remember the symbol for parallel looks like 2 L's. Okay, and we're doing this in a coordinate plane. So we're talking about an XY pair, and we just did this up here. It's where we would take both coordinates and multiply them by the scale factor. So that's what they're looking for down here. This is what this means. Okay, it means that you're multiplying both coordinates by the scale factor, meaning the x comma y pair. Okay, there's 4 points. You would multiply all 4 by that scale factor. Okay, flipping it over to the back. Okay. Now, when we were working on this question, we have to read it very carefully. Which of the following is the image, meaning this one is the before, we're trying to find the new one, After a reflection, if you don't remember reflection, it means to flip something. In the line of y equals x, and then dilate it. Okay, so remember, a dilation is going to make it big or small by multiplying by the scale factor. Okay, so first things first, I'm going to plot this point for negative 4, 10. There it is. I'm going to give it a label just so that we don't get confused. Now I need to reflect it over y equals x. So you have to remember y equals x is a diagonal line through the origin with a slope of 1, 1. So I'm going to start at the origin. It's been basically connecting a corner point to this corner point here. So straight edge, this way I can connect them and get the correct line. That ought to do it. There's that line of y equals x. So now I'm going to flip this point over this. Now if you don't have petty paper at home, we'll do it by the coordinate grid. Okay, so since this has a slope of rise 1, run 1, we're going to go down 1, right 1 to get to the line diagonally, as this is a diagonal line. So if I do that, I can count the diagonal boxes. 1, 2, 3, 4, 5, 6, 7. So now I'm going to go through 7 diagonal boxes again. 1, 2, 3, 4, 5, 6, 7. See the location of A prime. And if we look very carefully, this just became 10, negative 4. So when we see y equals x, it just means to take your coordinates and switch them. Okay, not so bad. But then it wants me to do the dilation. Okay, I have a scale factor of 3/2. What does that mean? I'm going to take both of these points and multiply them by 3/2. So I'm going to do 10 times 3/2 and negative 4 times 3/2. That's going to get me to a double prime, which is what they're looking for. Right? So 10 times 3/2 is 15. And you could type it into your calculator pretty much as 10 times 3 divided by 2. Hit enter, it gives you 15. You can do the same thing here. Negative 4 times 3 divided by 2 is going to give you a negative 6. So these are the correct coordinates of a reflection and then the dilation by 3/2, which is choice 2. Okay, for the bottom one. Segment AB, here it is, has the endpoints of negative 1, 4 and 4, 2. Plot the image of AB after a dilation by a scale factor of 3. Now remember, the scale factor of 3 is what you're going to multiply by. And the center at the origin. So if this is the center at the origin, it just means that it's going to grow 3 times out. Same thing with A. It's going to get 3 times bigger. So from here, it's going to go up 3 times. Okay, so multiply both of these by 3. Times by 3, times by 3. A prime would be negative 3, 12. Same thing here, multiply by 3. That gives me 12, 6. Right. So it does tell me to plot the image, which means I actually need to plot these points. Negative 3 up to 12. There's A prime. B is 12 and then up to 6. I'm going to connect these. Now, if I did this correctly, we did learn that the slopes should be the same because I need to get the segments to be parallel. So this is easy to find the slope here. This is down 2 and right 1, 2, 3, 4, 5. -2 because it went down over 5. The slope of A prime to B prime. So I'm going to count how many down, how many to the right this is. 1, 2, 3, 4, 5, 6. Down 6 and right. Did it correctly. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But if you notice, this slope will reduce to the slope of AB. Why? Because AB should be parallel to A prime, B prime after a dilation. And the last thing I'm going to do is ask me to find the length. So we kind of already created our right triangles when we were calculating the slope. So the length distance is generally, I remember it as rise squared plus run squared. I take the slope and I apply the Pythagorean theorem to it. So I get -2 squared plus 5 squared. Do the math. That's 29. So the length of AB is radical 29. Okay. Now if I did it correctly, the length of A prime B prime will be 3 times this amount. Well, what does that amount to? It means 3 times radical 29. That's what it should come out to be. Now I'm going to prove it. It does want us to prove it. Okay. I'm going to take the rise squared and the run squared. Now don't use the reduced form because that's only going to find you the length from here to here. I need to use the original slope because it's all the way from A prime to B prime. So I'm going to use this -6 and I'm going to use this 15. So rise squared plus run squared. Okay, just pulling up the calculator. All right, -6 squared plus 15 squared. That gives me 261. Okay, and at the end, yes, you have to take the square root of these numbers. What's going to happen is that this is going to break into 2 numbers. Radical 9 times radical 29. Where this is my perfect square, that gets me back to 3. Does it verify what we learned about dilations previously? Yes. 3 times AB gave us A prime, B prime, which was 3 times radical 29 is what AB came out to be, 3 radical 29. So it does work. Okay, if you have any further questions, please see me for extra help.